All right, let's dive right into one of the most fascinating and honestly kind of mind-blowing ideas in AI today, knowledge transfer. We're not just talking about how humans teach machines anymore, we're talking about how machines are starting to teach each other.
So let's just kick things off with this one big question. Imagine an AI that's an absolute expert at something, say spotting a rare disease on a medical scan. What if it could just, instantly pass all that expertise to a brand new AI?
Well, here's the thing. They can. This isn't science fiction. It is happening right now. And it's creating this incredible ripple effect, this explosion in AI capabilities that is changing the entire game. So let's get into how it works. Okay, to really wrap our heads around this, we've got to start with the basics. What do we even mean when we say knowledge transfer in the world of AI?
At its heart, it's all about moving learned skills, mental models, even a deep kind of intuition from one place to another. And look at the key phrase here. It's not just machine to machine, it's between AI agents and humans.
Now this is where it gets really interesting. This breaks down the two main highways for knowledge. We're all pretty familiar with the first one, right? Human to AI. That's just classic training. We give the AI data, we give it feedback, it learns. But that second column, AI to AI, that is the revolution. That's where one AI can just directly hand over everything it's learned to another one, and that opens the door for some seriously explosive network-wide learning. So how does this actually happen? What are the real techniques, the plays in the playbook, that let one machine teach another? Let's break down the three big ones. First up, you've got the most direct method imaginable, just copying. Seriously, think of it like this. You take a master chef's entire recipe book, every single note, every secret ingredient, every technique, and you just photocopy the whole thing for a new chef. It's a direct copy of the AI's brain. Super fast, but, as we're about to see, it has its downsides. Next, there's a much more, elegant approach called model distillation. So instead of photocopying that giant, messy recipe book, imagine our master chef sits down and writes a one-page cheat sheet with all their most important tricks and intuitions for an apprentice. That's basically what a huge, powerful teacher AI does for a smaller, more nimble student AI. And this shows you the trade-off perfectly. The teacher model is this massive behemoth. It's incredibly powerful, but way too slow and expensive to use on, say, your phone. It has what the experts call dark knowledge, this deep, almost gut-level understanding of the data. The student model then learns all those key patterns, but becomes a super compact, fast version you can actually deploy in the real world. And finally, we have federated learning. This one is an absolute game changer, especially for privacy. Imagine you want to train an AI on sensitive patient data from 10 different hospitals. Legally, they can't just pool that data together. So with federated learning, a central AI sends a copy of itself to each hospital. The copies learn on the private data locally, and then they only send the learnings, the updates, back to the center. The private data itself never ever moves. So if you lay it all out like this, you see there's no single best way to do this. It is all about the trade-offs. Copying is crazy fast, but not secure at all. Distillation gives you a lean, mean final product, but you have to build that giant teacher model first, which costs a ton. And federated learning is amazing for privacy, but it's definitely a slower, more complicated dance to coordinate. And hey, before we move on, we have to remember that humans are still absolutely essential in all of this. One of the most important methods for that is called reinforcement learning from human feedback, or RLHF. Basically, a bunch of people look at different AI answers and rank them from best to worst. That creates a whole data set of human preferences, which is then used to train a reward model. And that reward model then becomes like an automated coach, constantly fine-tuning the original AI to be more helpful and, more aligned with what we actually want it to do. Okay, so let's zoom out. All these things we just talked about, copying, distillation, federated learning, they're not just happening in a vacuum between two AIs in some lab. Nope, they are the individual bricks being used to build something so much bigger. What we're really seeing here is the beginning of a global network where AI knowledge is just flowing constantly between different AIs, different companies, even different countries. It's less like one single brain and more like a whole nervous system for the planet. And this global brain has a few key parts. First, you've got the actual networks, right? The pipes that connect everything. Then you have shared world models, which is a fancy way of saying all the AIs agree on a basic map of reality so they can work together. You've got rules for information sharing, ways for AIs to do joint learning on a problem together, and even things called exchanges, which are basically marketplaces, like an app store for buying and selling AI models.
Now, this all sounds pretty incredible, but if you can instantly copy an AI's genius, you can also instantly copy its flaws, its biases, its mistakes. And that brings us to maybe the most important part of this whole conversation. How do we do this safely?
So we have to ask the really tough question. What happens when this whole process goes haywire? What if bad knowledge starts spreading through the system like a virus?
And the risks here are no joke. A single flaw in one AI could be copied to thousands of others in an instant. A hidden bias could be amplified and spread globally. Not to mention things like outright theft of intellectual property, or errors that pile up and cascade through the whole network. Or even weird stuff like AI is learning to collude with each other in ways we never ever intended.
So, how in the world do we stop that? Well, we have to build guardrails, strong ones. That means having clear, standard rules for how these transfers work. It means every AI needs what's called a model card. Think of it like a nutrition label, spelling out what it can and can't do. We need brutal, rigorous testing. And this is a huge one, provenance. A way to track an AI's entire history, like a digital birth certificate, so we always know where it came from.
So let's tie all of this together and look to the horizon. With all this complexity, what's the point? What is the future that we're actually building here?
The ultimate promise, the reason we're doing all of this, is to just massively accelerate learning. The dream is to create AIs that don't just get good at one tiny thing, but can take what they know and apply it to totally new, really hard problems. Things like curing diseases or tackling climate change.
And this quote from the source material really just hits the nail on the head. This isn't just a tech problem, it's a socio-technical one. We're designing a system where knowledge will flow between people, machines, companies, and entire countries. The rules we make for that system right now are going to define our future.
Which leaves us with one final, pretty heavy question to think about. In a world where intelligence itself can be copied and pasted with the click of a button, who's actually responsible for what it does?